All right, for today's Algebra 2 class lecture, we are going to start by going through our homework problems. We will take questions for these on Thursday. So if there are any that you missed or anything else, then we can go over that then. We're going to do the answers. We're going to kind of do like what we do in class. I'm going to tell you the answers, but this time I'm going to write them on the board since we're in a recording and you can't stop me and have me repeat. So let's go through. We're going to go through these just as quick as you can pause. I'm going to say number 20 is, that's probably a bad idea, huh? Because that might, there you go, arrows be better so it's not negative, right? Number 20 is the ordered pair 8, 1. Number 22 is the ordered pair negative 1, 1. Number 24 is the ordered pair 1, negative 6. Number 26 is infinite solutions. Yes, you can just write the symbol. It's fine, right? Let's see. Number 52. Let me turn my page. Number 52 is ordered pair 3, 3. Number 54 is the ordered pair negative 5, negative 4. And 56, let's see, we went through 60, yeah. 56 is the ordered pair negative 5, negative 3. And 58 is the ordered pair negative 2, negative 4. And then finally 60 has infinite solutions as well. We didn't get any that didn't have any solution on these. We'll have to practice some more of those. I think we had that on our last homework set. So that's fine. But yeah, there are the answers to your homework problems. Again, we'll take questions on those on Thursday and do all of that. So let's jump in. Let me pause this recording real quick and get us. Okay, let's get started. Yes, you read that right. Lesson 4. I know we just did lesson 1, but we're going to actually skip lessons 2 and 3, and we're going to go straight to lesson 4. Lesson 4 is going to be over 3x3 systems. So if you remember from the other day, what do the 2 3s mean? So we have 3 variables in these problems. And since we have 3 variables to solve for, we have to have 3 equations. Weird O's are weird O's. So we're going to jump, like we do often on this, depending on what we're talking about, we're going to jump straight in with an example. Okay, so let's dive in with an example. I'm going to kind of format this video a lot like what we do in class, where we're going to do an example together, and then we're going to kind of do a guided practice one. Now, of course, you could cheat on the guided practice ones and not pause the video and whatever else and just get to the answer, but excuse me. But I strongly recommend that once we get to the guided practice ones and I tell you to pause the video and try them yourself, that you try them yourself. You'll get a lot more out of it that way. So this is going to be example number 1. Example number 1 is going to be this system. I'm going to do big old curly brace to keep it all included. And we're going to have these 3 equations. We're going to have 3x minus 2y plus 4z equals 35, excuse me. And then for the second one, we're going to have negative 4x plus y minus 5z equals negative 36. Okay, and then the next one is going to be, the last equation is going to be 5x minus 3y plus 3z equals negative 31. Now, what are we talking about here? So before we jump into solving this thing, you know, when we do a 2x2 system, remember what we're talking about is we're talking about a coordinate grid with a couple of lines on it. And the solution to that, these are not lines, but they're close enough, right, to get the point across. The solution to this system of two equations, 1, 2, is where they cross, right? Well, so what is a 3x3 system mean? Well, it's actually the same thing, but this time instead of doing a two-dimensional coordinate grid, we have a three-dimensional one, right? Drawn, kind of sketched roughly a little bit, right? Looks something like this, right? This is what we're talking about. So we've got a thing in 3 dimensions here. This one would be solid as well. There we go. Something along those lines. That's more or less right? To where we have the z-axis coming out of the page, right? And then we have the x-axis and the y-axis. This is not actually usually how they're drawn, but this is where, since this isn't like Calculus 3 or linear algebra or any of those classes, this'll get us close enough. So we're doing the same thing, and it's going to be hard to visualize, especially in a really quick sort of a way, but we're still talking about 3 lines and where they cross, right? We might have a line, that's just one line, of course. Why would you say otherwise? We might have a line that's right there. We might have a line that's going into the page right there. And then we might have another line that's going into the page right there and coming out here, coming out there. And they all 3 cross in one place, right? So that's what we're talking. We're still talking about where the lines cross, and that is the solution. You can actually kind of solve these by graphing. Now, it's going to be much more difficult in 3 dimensions because it's much more difficult to graph a 3-dimensional system in 2 dimensions. You end up having some sort of weird mess going on, and we don't want that. So even more than before, we're going to solve these with algebra, okay? So we're actually going to use elimination to solve this equation. So what we're going to do, I'm going to number these for the sake of discussion. So this is going to be equation number 1, this is going to be equation number 2, and this is going to be equation number 3. That way, when I say equation number 1, we're all talking about the same thing, right? So what we're going to start by doing is we're going to rewrite equations 1 and 3. So equation 1 is still 3x minus 2y plus 4z equals 35. Did I start my recording back? I hope I did. I totally did. Let's see. So, all right. So, and then we're also going to write equation number 2. So we're going to write negative 4x plus y minus 5z equals negative 36. All right, so what we're going to do, like I said, we're going to use elimination on this. And we're going to eliminate just one of the variables. Now, there's 3, so it's not going to be quite as fast, which probably should have expected it to not be as fast since we're solving a much more complicated thing here, right? Well, if you end up doing an engineering class and doing a circuits class and things like that, you might even have 4x4 systems and more complicated. And there are ways to solve those by hand and whatever else. And then there's also calculator programs that'll do it for you when you get to college and do all those things. But back to reality and back to where we are. So we're going to eliminate the y. So in order to eliminate the y, remember, like our other elimination, we want them to be opposites. So right now the signs are opposite, but the numbers are not. And so what we're going to do is we're going to multiply this second equation times 2. So we're going to multiply everything times 2. And I'm going to rewrite that. Okay, so 2 times negative 4x is negative 8x. And 2 times y is plus 2y. And then 2 times negative 5 is negative 10z. Whoop, I didn't say z, but I think you get the point. And then finally, negative 36 times 2 is negative 72. All right, so so this one corresponds, of course, to equation number 2, right? I'm going to rewrite equation number 1 right below it for clarity's sake, right? So I'm going to rewrite 3x minus 2y plus 4z equals 35. Now, just like a 2 by 2 system, when we eliminate, we're going to draw us a line, and then we're going to combine the different terms that go together. So let's see, this goes with equation number 1. So I'm going to keep up with what's happening here, right? So negative 8x plus 3x is negative 5x. And then these cancel out, which is good because that's what we want to happen, right? So, and then negative 10z plus 4z is negative 6z equals, and then negative 72 plus 35 is negative 37. All right, so now we have a 2-variable equation. I'm going to label this one as 1 plus 2. All right? So that's what that one is. We following so far? I hope so. You can't say no, I'm not. But if you have questions, especially after I assign some homework, then we'll take those on Thursday. We'll spend most of Thursday going over questions, depending on all this from this lesson and from the last lesson. We'll make sure we're all good on Thursday. So don't stress. All right. So let's keep on going. Keep on keeping on. So we have an equation that is a 2-variable equation with x and z in it. So our next step, let me erase all of this mess so I have room to do the problem I'm trying to do. What we're going to do now is we're going to combine equation 2 and equation 3, right? So I'm going to rewrite equation 2 and equation 3. So here's equation 2, which is negative 4x plus y. Negative 4x plus y minus 5z equals negative 36. And then equation number 3, which is 5x minus 3y plus 3z equals negative 31. All right, so in order to do that, now we could have taken 1 and 3 as well. We could have done that as the second one. There's like I said before, there's always more than one way to solve these, but this is the way that looks easiest on this one, so this is the direction we're going to go. Now, on this guy up here, we need it to match this other one over here. So in order to make it match, what we need to do is we need to cancel the y's again. So we're going to, in order to make these y's opposites, we need to multiply this equation number 2 times positive 3, right? So we're going to have a rewritten equation number 2, right? That's multiplied. So negative 4x times 3 is negative 12x. And then 3 times y is plus 3y. And then 3 times negative 15z, negative 5z is negative 15z. My brain gets ahead of my mouth sometimes. It's a little bit terrifying. And then 3 times negative 36 is negative 108. Right? Excuse me. And then we could just kind of go straight on with that, but for clarity in the video and all that kind of stuff, I'm going to take my time and rewrite equation number 3 below this one. That way we keep things all clear and neat and all of that. So it's hopefully we're making things real clear and easy for y'all to follow along. And when we do have questions on Thursday, we won't be completely and utterly lost. So negative 31. Now, then just like before, we're going to eliminate. All right, so negative 12x plus 5x is negative 7x. These middle ones cancel out, which is great because that's what we want to happen. And then negative 15z plus 3z is negative 12z. And then this last one, we have negative 108 plus negative 31. So we have negative 139. All right, now, so this one we're going to label as 2 plus 3. I don't know why sometimes it makes pretty ovals and sometimes it doesn't. Maybe that was because of that little tail there. Who knows? All right, now look what we have. We have something that we've learned how to deal with before. We have a 2 by 2 system, right? Because we've got two variables, x and z, and then we've got two equations to deal with them. All right, yippee skippy. Now we know what to do with that. So I'm going to rewrite those equations. I'm going to keep them labeled, keep things neat. You don't necessarily have to do this, by the way. This is it's not a terrible idea for you to do it. It's just I'm mostly doing it for the sake of the video to keep everything real clear and to keep our notes really clear, especially when I save these notes out. Y'all remind me in class. I'll try to do things more like this. Take a little bit of time to do things like that in class as well. That way, when you're going back and looking at the notes, then it's easier for you to follow along and understand what's happening, right? 37, and then we're going to put equation 2 plus 3 over here, which is negative 7x minus 12z equals negative 139. Now you can solve this again with either substitution or elimination. What I'm going to do is I am going to solve it by elimination because I'm going to eliminate the z's because I can just multiply this top one by negative 2 and then they're opposite. So that seems like the best way to go there. If I went with substitution, I'd end up having to deal with some weird fractions, which would be okay, and we could handle that, but I think this is going to be the more straightforward way on this one. So we're going to multiply the top one times negative 2. Later, when we learn about matrices, you could do this one with determinants as well, or even Gauss-Jordan elimination. Yeah, both. All of the above. Well, I guess Gauss-Jordan elimination is kind of determinants. I don't know. You'll see when we get there. Then we have negative 10. Excuse me. I'm messing up because I'm talking about too many things at once. Positive 10 x plus 12z equals, let's see, 2 times 37 is 74. Oh yeah, I could have done that in my head, huh? It's all right on video. I'd rather put down the right number and act like I need a calculator than otherwise. So this was equation 1 plus 2, right? Blapo. And then we're going to rewrite equation 2 plus 3 below it. All right, so this would be negative 7x minus 12z equals negative 139. All right, then we're going to combine those. I'm gonna quit my notation because this will be 1 plus 2 plus 2 plus 2 plus 3, and it's just going to start to get ugly and convoluted at that point. So I think I'm going to leave this where it is. So 10x plus negative 7x is 3x. These middle terms cancel. This middle term, the z's cancel, which is great because we want that to happen. That equals minus 139 equals negative 65. Sorry for the weirdly awkward pause. I thought that I had done something wrong, which I did because I copied down the problem wrong to begin with, but that's okay. We're just going to get a slightly different answer than the one from the book because this was actually an example from the textbook, but that's fine because we didn't do anything wrong and it still all works out fine. We're just not going to get a pretty whole number answer, which, annoying though it may be, is still an answer. Fractions are just numbers, right? So the last thing we're going to do, of course, to solve this guy here is to divide by 3. We're going to divide both sides by 3. This 3 over here cancels, so our x ends up equaling negative 65 thirds. 3 doesn't go into 65, so that's as simple as that gets. So there's our first answer, right? So what are we going to do next? Right? Of course, what we're going to do next is we are going to take and we're going to substitute this guy, and our best plan is to substitute it into one of these two equations, right? So we can substitute it into either one. Let's see, we're substituting into x, so either way it's not going to cancel. So, you know, we've ended up with ugly fractions and whatever else, which is fine, no problem. Let's do it with the smaller numbers, I guess. So we're going to take this and we're just going to substitute it into right here, right? So let's go ahead and do that. So we're going to end up with negative 5 times negative 65 thirds minus 6z equals negative 37. All right, so I have to go nice and slow so I don't make a mistake because I don't have the key to check myself on, which is I should have done a long time ago, and then I would have caught the mistake sooner. But either way, it's totally fine because y'all get a good example, because these won't always end up with pretty whole number answers. Most of your homework will, though, so don't freak out and get scared. So we end up with negative 5 times negative 65 thirds. So, oops, hold on. 5 times 65 thirds equals positive 325 thirds. Sorry for the weird pauses. Again, I'm trying to make sure that I double check stuff and not just do stuff in my head. That way I don't make any just math mistakes. All right, equals negative 37. I haven't looked for sure at the key on the homework assignment yet. But if you get weird answers like this on your homework, you probably did something wrong, because I think they'll all turn out pretty and won't turn out horrendous and ugly like this. Just know that this is just going to be a weird example. I'll make sure and copy down the guided practice ones right as well. That way we're doing really, really well. So we're going to subtract the 300. What am I writing? We're going to subtract 325 thirds from both sides. What a fun number. Real life is rarely even, though, despite what Pythagoras might have said. Life doesn't, although even this problem would have made Pythagoras happy, because this one still is whole number ratios. We're not dealing with irrational numbers. So that number, let's see, 37. So we end up with negative 436 over 3. You know, it's going to be kind of crazy. Oh, no, we're not going to quite. I thought for half a second we were going to end up with a whole number answer, but I don't know that we will. So we're going to divide that negative 6 off, divide the negative 6 off. So we're going to divide that by 6 equals. So our final answer for Z equals positive, because a negative divided by negative, right? 218 over 9. Right? So there's our z. I don't know why I decided to circle it, but I did. So we have x and we have z. Now what we can do is we can take and we can plug the z in for a z up here. Let's do the one with y already by itself. So we're going to take and plug this into equation number 2. I'll write it here on my notes, and we're going to plug the x in for x on equation number 2. So that's what we're doing on this last little bit. I'll kind of highlight it down here as that's what's happened. So we're going to do negative 4 times negative 65 thirds plus y, excuse me, minus 5 times 218 over 9 equals negative 36. Now, let me zoom in. Kind of written ugly because of how zoomed out and weird my hand position was to get that. Let's double check, make sure I wrote the right numbers. I did. Double check with our equation number 2. Make sure it's still negative 4, nothing, and negative 5, and then negative 36. Yeah, looks like we're banging on all 8 cylinders. Okay, so we're going to do this and this first. So 4 times 65 over 3 it's going to be positive because negative times negative is a positive. So 260 thirds plus y. And then this one's going to end up negative, right? So let's see, 5 times 218 divided by 9 equals that. Convert back to a fraction. Equals negative 1090 over 9. Aren't these cute? Equals negative 36. Don't turn your brains off, by the way. I know a few of you are like, oh my gosh, this is terrible. And this is terrible because I copied down a wrong problem. But take it slow and remember, fractions are just numbers. These are ugly fractions, and it's caused by a mistake on my part, but that's okay because you can still do it, right? So do that minus that number. So we end up with excuse me. We're combining like terms. So we've got y minus 310 over 9 equals negative 36. So to get our final answer, we're going to add 310 over 9 to both sides. So that minus 36 equals, so our final answer for y equals negative 14/9. So our final answer is the ordered triple, negative 65 thirds, negative 14/9, 218 over 9. That is our final answer. So I'm going to put a guided practice problem on here. Then I'm going to pause, and then we're going to come back, and I'll show you the work, and so that you can check yourself and all of that kind of stuff and do all of that. So here is your guided practice problem. So this is what you need to do. I can't make you. I'm not standing there with you. I can't freeze the screen. Well, I can freeze the screen, but that's not gonna help and whatever else. But what you need to do is you need to take and you need to solve this one on your own. In a minute, I'm going to pause my recording, and then it's going to come back. So what I'm going to need you to do is I'm going to need you to press pause on this video, and then I want you to solve this one. What I would do, I'm going to give you a hint on this first one. I'm not going to give you a hint on the next one. But on this one, what I would personally do, now there's several different routes you could go, but what I'm going to do when I make kind of the key that you're going to take a look at in a minute is I am going to solve for, or excuse me, I'm going to eliminate the z's is what I'm going to do. So I would recommend doing that. And the reason why I'm choosing to do that is because this z down here doesn't have any number except for -1 on it. And so that's why I'm choosing to do the z's first on this to eliminate the z's, but you could go any route you want to go. So go ahead and pause the video, and then we're going to go in and, yeah, go ahead and do it. Pause the video and then come back and I'll have all the work up on the screen. So there is where we get in the answer. Did you pause soon enough? I hope you did, because here's the answer and there's the work. I tried to do a good job of color coding these bits and make it pretty clear at all of those things. So of course, solve for z. Our answer in the end is, let me change to, how about this dark gray? Our answer in the end is the ordered triple 3, -2, -4, right? So that's pretty straightforward. As our answer, it comes out real pretty. I didn't copy anything down wrong this time, which is great. Hopefully that made your life a little bit easier as well. So I started in this space right here, and I eliminated the z like I said I was going to do. I almost made a mistake on this. You gotta watch your signs, your SIGN signs. I don't guess I have to spell that out since this isn't pre-cal and trigonometry, but you have to watch your signs. I almost on this one, I started out by multiplying times +5 because I wasn't paying close attention to what I was doing. And then these weren't going to eliminate. And so I thought, oh no, I made a mistake, which was nice. It's kind of a self-correcting mistake. So I did that first. And then I took equations 2 and 3 and I eliminated the z's again. I ended up with this as my answer. This one was fairly straightforward, especially after making that mistake to begin with. I was real careful about my work. And then I, of course, took those two equations and set up a 2x2 system. Now, this was really cool and slightly unexpected. If you follow the same path, then hopefully you ended up where your y's just eliminate already without any multiplication, which was really, really awesome. We already have -11y and +11y. So they were just set up for elimination, which was really, really awesome. Hopefully y'all found out the same thing and did it the way I did it, because that worked out really, really cool. And so then I eliminated the y's and ended up with 14x equals 42, and then got x equals 3. Then I, of course, took and substituted that 3 back in for x, as you can see there. And so the work for that, I try to color code this when I save out these notes and put them places. Then I tried to keep it nice and color coded, neat, and easy to understand what's happening. So the work for that is over here. When I plug the 3 in, I ended up with y equals -2. And then I took and substituted both of those way back up into this equation number 3 up there. And the work for that is right here. And I ended up with z equals -4. So that's the work. If you have questions on this problem, if you didn't get the right answer and don't understand why you didn't get the right answer, make sure that you ask questions about it on Thursday. So let's do one more problem this same way. So I'm going to go ahead and write it down. And when I have it down on there, you need to make sure and pause the video, do the work yourself, and then come back in a second or two, unpause, and you'll get the work, and we will check it together. So equation number 3, system number 3, problem number 3 has these equations. I'm going to write them down slow enough that I don't copy them down wrong. So we've got 4x minus 3y plus 6z equals 18. Right? And then for the second one, it is -x plus 5y plus 4z equals 48. And then the final equation is going to be 6x minus 2y plus 5z equals 0. This time I'm not going to tell you which one I'm going to where I'm going to start and which variable I'm going to eliminate. You pick on your own. There is one that looks easiest to me, but y'all do whichever one feels right to you, and go ahead and do the work. Pause the video and then come back. I'm going to pause my recording, and so if you're not paused, you should go ahead and pause, or else you're going to jump into the answer real quickly. So be back in a second. All right, that problem was a little bit more irritating, partially because I made some mistakes along the way and had to fix them. So there's all the work, big picture. Let me walk through real quickly what's going on, the route that I chose. So I chose to eliminate the x's. You may have chosen something else, which would be fine, and you should still be able to check it off of the answer, which we'll get to in a second. So we started out with the problem, and then we did equations number 1 and 2 and eliminated the x's. So I multiplied the second one. Let me get my gray back out. Multiplied the second one times 4, right? And ended up with this number, or this equation, right? And then we eliminated the 4's and ended up with 17y plus 22z equals 210. This is actually the first mistake I made. I accidentally wrote negative 20 right here for some reason. And so I did all of this work with negative 23 as right here, and then realized that I was getting something stupid, and so I had to have made a mistake, so I had to walk back through what I was doing. So that was the first mistake I made, was watch again. You got to watch those signs. Slow down. You got to slow down and double check every sign. Those are a big deal. Even I make mistakes on those, especially when I'm doing them, trying to do it quickly, get these videos out to y'all and all of that kind of stuff. So take your time, do it right? Now, the next thing I did was I took equations 2 and 3 and I eliminated the x again. So I multiplied the top one times 6 and I ended up with this right here. Okay. So there's that guy. And then when I eliminated the x's, put those together, ended up with 28y plus 29z equals 288. Kind of ugly numbers, but it works out. Now, so we ended up taking this 2x2 system right here. Now, I tried for a second or two to find something smaller to multiply by, but I couldn't find something quickly, and so I was like, whatever. I'm just gonna jump, and it's probably gonna save me time to just go ahead and multiply by eliminating the y's, right? So multiplying this top one times negative 28, which is the opposite of that number, right? That's where I got that from, and I got this right here, right? And then the bottom one, I did the opposite, or I didn't do the opposite, but I did this number so that then they would match, negative 476 and positive 476. So if you can't find something quickly that's smaller to multiply just one of them by, or some smaller number or whatever, then you can, excuse me, then you can just pick the opposite, make two opposites by multiplying by the other number, essentially, is what I did there. And so I ended up with negative 476y minus 616z equals negative 5,880 at the top from this one. I took that one and it ended up there, right? And then on the second one, I multiplied all of these times 7, and I ended up with 476y plus 493z equals 4,896. And then when I did the elimination, we ended up with z equals 8, right? So the first thing we did with the z equals 8 is I went and plugged it back up in here, and then that's where this section right here happened, right? And so I plugged that z in, and the work, my computer is freezing up on me. There we go. The work for that is right here, plugging the 8 in for z, and did all of that and ended up with y equals 2. Then, of course, we had to take and plug both of those. I chose to plug it into the middle one. Probably just as easy would have been to plug it into the third because of this 0 right here. That makes for some nice clean stuff. But I decided to kind of use the same sort of path that I have been going on the other ones because I figured that's probably the most likely for path that y'all went down. And so I put it into this one because the x is kind of by itself with a negative in front. And so once I did that, of course, this is the work for that. Plugging in the 2 for the y and the 8 for the z. We ended up doing our work. This is the second mistake. I was going fast because I was tired of this problem. It was already taking a long time, and I accidentally did that for a 0 or something along those lines. And so I made them. This is, again, when you go fast, you end up taking more time. So take your time at the beginning, and you don't have to take more time later. And so I accidentally made the mistake of writing 16 right here instead of 10. And so I ended up with 48 equals 48, and x was equaling 0, which, is, of course, normally a perfectly acceptable answer, but I've got the key in front of me, so I knew that wasn't the right answer. So I had to go back and realize what I had done, and that this should have actually been a 10. So 10 plus 32 is 42, not 48. And I ended up with x equals -6. And for my final answer, I ended up with the ordered triple -6 to 8. So there are the examples we're going to do. Let's go ahead and put our homework down, and then y'all can get started on that. Again, we're going to take questions over homework from this set and the next set on Thursday. So here is your homework. So it's on page 165, and we're going to do numbers 6 through 18 evens. These are all 3x3 systems. That's why it's a little bit shorter. It's also a Monday. And so y'all take care of those. We'll go over those on Thursday, give you the answers, and we'll take questions on those. I will tell you right now, there is at least one problem that has either a no solution or infinite solutions. That works the same way as a 2x2 system. And number 18 is a word problem. So take your time on those, do your best, and we will work on that some more on Thursday, and we'll make sure you're good on these system things before we start looking at matrices and solving systems that way next week. Y'all have a great couple of days. See you Thursday.